Hello. Okay. So, can you hear me?
Yeah.
Okay.
So,
Very fancy.
so did you catch a cold? So how you wear the mask?
Mask.
You got
And
you
yeah,
got
maybe mostly I wear mask because
you
I
got
afraid to catch the
you catch a
fever.
cold.
But
Yeah.
last October I had a COVID, so that is
Ah,
I'm
okay.
afraid.
Okay.
Yes. Are you a student in their home?
Yeah.
Oh.
In the
In
dormitory.
yeah,
Dormitory.
in a dormitory.
Yeah.
Huh? Yo? No. Dormitory.
Dormitory, yeah.
Yeah,
Okay.
dormitory.
Not
I
his home.
Yeah, it's not my home. It's not my home.
oh
I just rent it.
Actually, he lives in Taipei.
yeah
Yeah.
Yeah. And his parents both of Hong Kong, or from
Oh,
Hong Kong.
Have my father is from Hong Kong.
His
Yeah.
father is from Hong Kong.
Yeah.
we will visit to Hong Kong.
Yeah.
In your home. Hong Kong 行きたいんですって。They won't go want to visit to Hong Kong.
Really?
大丈夫。
Yeah.
Really?
Shall we go to Hong Kong?
Yeah.
So,
Together.
so when you go to Hong Kong?
When like winter vacation or summer vacation or the New Year.
Summer vacation is coming soon.
Yeah. Maybe we'll go back to Hong Kong.
Okay, let me call Professor AKB and Professor Jerry to
Yeah.
attend the conference.
Yeah.
なんか熱くない？大丈夫。これちょっと調整して。
でも、ちょっと最初参加してね。
いやいや、
途中で後で戻っていいよ。
無理
最初。
です。
あと、学会のことも言う。見てよ、私のあれ、悪くなったね。
捨て方悪いです。
見て、
捨て
捨てる気がないね。
いや、でも十分いいじゃないですか。味が出て。
見て、ボロボロあとね、
気のせやん。
ボロボロね。
綺麗じゃないですか。も
わあ。ボロボロなったか。
う、先生どれ買ってもボロボロになりますよ。
我们可以清楚。
か。
我记得我之前都很
何回のね、
さん、冷めてない。
スピーカー、セクションとかで私入ってない。
あ、本当ですか。
そう、ストゥーデンコンピティション、ベスピーカーコンピティション、合計グループ。まあ、4年と同様。
頑張ります。
4年と同様ね。で、発表しがないじゃん。
そうですね。
ね。
発表しかないんですか。ペーパーないんですか。
ペーパーも出ました。コンピティションですよ。先のスケジュールで書いたよ。
本当ですか。
構図で出まし
なんかもうペーパー僕取ってないってことですね。
で、そこに入ってない。入ってない。入ってないね。でもどこ行くの？ Were you online? Not yet. They forgot.
So they didn't respond me. Okay, I think maybe we start to our meeting right now, and maybe they will attend this meeting very soon. So how about Professor Cici? How about you think? Yeah,
Yes.
okay.
It's okay. Shall we start? Yeah.
Yeah, because it's time too late in Japan, right?
It's okay. It's okay.
Okay, so let me ask Wei Yuan to and the Bo Yun
Yeah.
to present
How
their
about the
slide
New Year guy?
during the past month.
New Year guy? Where is New Year guy?
Noodle guy.
Noodle guy. Okay,
guy.
noodle guy. Yeah, I know.
Noodle guy have in the meeting, but he don't have speak. And you see my screen.
Okay, yes.
Okay. Okay. So we developing a Coco style kettle skeleton annotation method. So we will start. We will make the kettle key point standard and animal skeleton annotation. Axis animal skeleton model are most used for post estimation and behavior. And however, before model training, there is still a lack of clear guidance on how key points should define annotation and validate. So the problem in currently annotation method, why should the key point be annotated? Inconsistent result across here, annotator. And why this key point responsible lack of an anatomical base for the model. How can annotation accuracy be validated? Dataset query become difficult to choose. Therefore, this study does not only focus on post-recognition result, it aims to establish and explain a notable and verifiable kettle skeleton standard. How should kettle skeleton key point be standards? Use 3D kettle anatomy to convert anatomical joint into a image label Coco from key point. Cautions to answer before standard. Which body part should be included as kettle key point? And where should each key point be placed anatomically? And how should occlusion or posture variation be annotated? How can consist and accuracy be maintained across annotators? So we find this 3D kettle anatomy. This reference, you can know the skeleton of the kettle and the muscle and the skin and some other, and we can know the correct point to labeling. So we see this 3D anatomic model identify bones and joints. We can see here, and we can know where is can put the skin on this picture, and we can know where is the correct point. And image key point confirmed to label coordinates. And Coco skeleton define key point and connection. And annotation grounding line define visible and QA rule. And this slide explains our ground truth construction process. On the left-hand side, we show the common workflow used in POCO and other key points data set. It uses including image selection, target define, manual annotations, expert review, or quality control. And finally, explore the Coco JSON format. In our case, the main challenge is that P skeleton key points don't have a mature standard like human key points. Also, we certainly don't have an expert to review process to check every annotated point. As a result, if we rely only on major judgment, the key points location may become inconsistent. Therefore, this is our proposed workflow in the right hand side. It is similar to the Coco workflow. But the key difference is that we add a 3D anatomy reference step. By using 3D anatomic model, we first identify the skeleton and joint location, and then convert them into key points that can be annotated in 2D images. In short, we use 3D anatomy to support the annotation process, so that our ground truth can be more consistent and suitable for data model training. One certain limitation is that the 3D anatomic software we found only provide a pig model in a standing posture. So we are still looking for other 3D models that better match our data set. And this is our report.
Okay, so Cici, Professor Cici, so and your student, so do you catch the point of their presentations?
Okay, so this time, so you focus to the anatomical point for the anatomy, cattle anatomy model to change from the, how to say, the specialized key points to the anatomical point. It is.
Yeah, so please go back to the first slide. So actually, there is no AI model which can be used to recognize the skeleton or key point of the cattle, like the human bodies. So as I asked your student before, how can we build up the ground truth, the ground truth of the joint or key point for the cattle, which is recognized by the AI models. So we don't know how to label the key points of the cattle images. So first one, we learning from the 3D. So please go back to the slide. The 3D skeletal image. Yeah, like this. We learn from the 3D cattle skeletons image, the video like in the right hand side of the slide, and we can note how many joints or how many key points of the cattle animals, and we try to label the right key joint on the cattle images to build up the data set and put them into the AI servers for training purpose. So we try to generate the AI models which can recognize the key joint of the cattle for their whole bodies, and then we can use the key joint informations to develop the algorithms which can be used to recognize the behavior of the cattle, like their walking or rumination or eating or the sitting or the climbing, like these behaviors. So that's why I ask my students, we want to construct the first the first key joint or skeleton data set in the world, and training the AI models, which can be used to recognize the right key points of the cattle image. Yes, that's our first work. So, so do you catch my point?
Okay, so according to this figure, so you will recognize the anatomy key point of the whole
Yes.
body or the particular region. Which one?
Yeah. Yes. And we can use these 3D images to know where is the key points of the cattle, and use this information to label the cattle images to control the data set.
So for 3D image, so you will use the original RGB data from 2 camera or another 3D camera. Which one?
Oh, no. Only 2D images, because the 3D image is just a tool. So we need to we find the tool. We have to buy the tools. This tool can show the 3D skeletal image of the cattle when he only stand up, of the stand up behaviors. So we use this skeleton 3D skeleton information to know where is the key joint of the cattle, and we can learning the key joint and label the right key point positions on the 2D image of the cattle. For example, when the cattle is standing like this, so we can learning, oh, here is the key joint of the eye or of the mouth or of the leg. We know the joint, where is the knee, the joint of the knees or the foot.
Okay, so at first the input image is the original RGB image, and you will change to the skeletal image like this, skeletal image. So in that sense, it depends on the input, for example, the Holstein image or the black image. So it depends on the input species of the cattle or not.
Not really. I think so. William, could you please put the provide the pictures of the cattle whose behavior is standing?
找一个图片是这样子。On the website or
It's okay. what I mean is that, so when we want to label a 2D image of the cattle whose behavior is standing up, so right now we don't know where is the key joint of the cattle, right? We don't know. So we know how to label the key joint of the cattle. And we don't know how many key joints we can label on the 2D image of the cattle. So we, first one, we learn from the 3D models. So we can know, oh, right. If so on the leg, we have, yes, like this. Okay, yeah, I think this is a cattle, right? So, so if we want to label the cattle, the key joint of the cattle, we don't know how many key points we can label on the whole bodies, right? So City, we don't know. So how many joints if we want to control the data set of the AI models, which has the key joint informations of each 2D cattle images. First, we have to label the key joint of the 2D image as the data set to construct the data set, but we don't know where is the key joint of this 2D of this 2D image of the cattle. This is our problem. We first problems. Even though we don't know, right?
So the purpose is to determine the behavior of by using those skeleton features. Is right?
Yes. So the problem is okay. You go first. You say first.
It's okay. So like this. So the cattle is alone, standing alone. It's okay. For in the ranch, so the cattle are overlapping. So
Yes.
Yes. Can do in that sense how we will extract those skeleton features for each cattle.
Like human body. So we want to control the AI models to recognize the skeleton information of the cattle, like an open pose, like the state of the art AI models, for example, the open pose or the YOLO pose models. So right now we want to develop AI models to automatically recognize the key joint of the 2D images for the cattle. This is our first work.
Okay, so for the standing and sitting is maybe different. It's okay. For the case of standing and sitting is we can differentiate by using those like open pose skeleton model is unclear. But for the rumination,
yes. So that's why so for the rumination and eating, so did you remember in the past several times for the presentations from Wei Yuan, we label the face key points.
Yeah.
Right. The 5 face key points, right? We label the 5 face key points for the cattle.
As I mean is, so for the skeleton information, so today presentation for the skeleton information, for example, we can know this is the cattle is standing. Okay, after getting the standing behavior, so we will use only those skeleton information to divide the how to say rumination and only the standing. So in that sense, you will use again for this slide or only the today's skeleton information.
Okay. Overall, we want we not only want to decide the key point of the face on the kettles. We also want to know the other joint, key joint of the kettle bodies, because we can not only recognize the rumination or eating behavior, but also we can recognize the other behaviors. For example, the cattle is standing up, or the cattle is sitting down, or the cattle is climbing on the others' kettles. So we can use the skeleton informations to determine such behaviors.
Okay, I get up. So
Yes.
you are today this anatomy key point model. Anatomical key point model is for differentiating the standing up, standing and sitting, and after dividing those two, for example, mainly two parts. So rumination and rumination or eating will be used there before our previous contents. Is right?
Yes.
We will combine both.
Yes. Yes. Combine both. Yes. Yes.
Okay, I get up. Okay, okay, I see. Okay.
Yes. Yes.
Okay.
Because in the past research result, we only just can recognize 5 key points on the cattle face, right?
Yeah.
So we only can determine the eating behavior or rumination behavior. But if we want to know more behaviors, such as the standing up, or sitting down, or lying down, or climbing up, so we have to know that we have to develop an AI tool which can use to recognize the key point of the whole body, and we can use such skeleton information to determine other behaviors. Yes.
So this time you will use those features not only using the only max region. Instead of the max region, you will use the skeleton model.
We want to develop the skeleton model,
I see.
skeleton recognition model.
Okay, I get up. Okay.
Yes.
Professor. So do
So
you
maybe
have
we can combine if we can develop the skeleton recognition models for the kettles, maybe we can do more recognition process for the kettle's behaviors, and can combine with your work. Maybe yeah.
We have searched some other using the cattle key point. It can know the cattle is healthy or not. It have a like this, the body condition score. This is use the cattle's hip and and you can know the cattle is healthy or not. But I have heard it. I think I don't remember have your lab have doing this or not. I forgot.
Give your job in the floor. That guy, yes, contacting the body condition score. Yeah.
Thing is doing this.
Yeah, in the same floor, in the first floor, same room. When you visit in our laboratory, give your job, one guy.
He is doing this is finished or
yes. Maybe this time he will present maybe about the body condition score on
okay.
Taiwan. Yeah.
Because
he used the 3D data. 3D data. We set up the 3D camera from the top view. And we get those depth data information. And he used the point cloud model.
Yeah, he have told this. He have told us that how he do it. So I think I don't know we need to do this or or not by the key point.
In that sense, for the body condition score, we are not using the key point, not all the body in the later part of the kettle body. We just only use the later part.
Okay.
Okay.
Yeah.
Okay. Yes. So maybe maybe we after we already construct the key point of the whole body for the kettles, and training the AI models, which can be used to recognize the key point of the kettle images. Maybe we can provide can open such data set for your lab, and we can discuss if we have such informations or if we have such AI models, we can do what kinds of more detailed kettle's behavior recognition research. For example, we can predict the kettle is healthy or not by recognize the kettle's detailed behaviors.
Yes, Professor. Yes. Yeah. Okay. You have some question.
So, to clarify, what you are trying to do is to construct a model that can recognize the key points in the cow. For example, whether no matter what it is doing, for example, whether it is standing or whether it's lying down or whether it is ruminating, you want to find out the key points so that we can use that data to further the research. Is that correct?
Yes. 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 Correct. So the major problem is how to. So why Wei-Yuan present his research is that the major problem is how to construct the AI models, which has capability to recognize the key points of the whole cattle image. How to. So that's why we do such work first. So we use, so as you can see in this slide, we try to use the 3D pictures to determine how to label the key nodes of the key points on 2D image of the kettles to construct the data set for training purpose, for AI model training purpose. Yes.
Okay. Yes, Professor. So your students are trying to make the 3D skeleton model.
No. 3D skeleton model is 3D skeleton model is also the well-developed tool on the website. Yeah, this one, the right hand side, of this slide is a well-known tools on the website.
So you are extract from those skeleton point or joint point?
We want to learn where is the how many key points of the kettles we have to learn, so we can label the correct number of key points or the correct position of the key points on the 2D image.
I think so. In that sense, I think for the objective, it is different the anatomical point. For the body condition score, for example, in our reference paper for 21 anatomical key point is enough for body cone. For other purpose, a different anatomical key point. So that is why we have to decide. So how many key points are necessary for what purpose?
Yes. if we want to use the key points information to recognize the detailed behavior, I think maybe we have to construct the skeleton key points as the human bodies. For their legs, maybe have 3 key points, and their face and their whole bodies. So, for example, for the pig, there's a 23 key points of the pig, right? So, Wei, how many key points we use for the pigs to recognize their skeleton
20.
information?
23.
Yeah,
For
the pig. So pig, we use the 23 key points on the whole for recognize the skeleton of the pig image.
Okay, I see, Professor. So do you have any question? Okay.
We use this
Yeah,
tool.
like here, this is an open tool. So we can use this tool to see each angles of the pig bodies and see the skeleton information in 3D.
So what is the difference between the pig and the cattle?
Yeah, good question. So I think it's very similar. Yeah, I think it's very similar. Maybe also we can define the 23 key points for the cattle. Yeah, here's the tool for the cattle. So we can see this open tool. You can see the skeleton of the cattle from different kinds, different view. Like this. So we just use this tool to learn and determine how many key points we need to label on the cattle images, and what is the correct positions we have to label on the 2D images to construct the real data set.
It's so interesting. So
yeah. So do you catch my point?
Yes.
Yes.
I see.
So right now we want to do another research work is that we want to build up the AI agent team and let them to learning the 3D cattle anatomy for their reference. So I think our AI agent team is the virtual AI team, virtual agent team, will automatically learning the key joint and define how many key joint or how many key points have to label on the 2D cattle images. And I think they will automatically label the 2D image instead of we label by ourselves.
So maybe next time, so we can decide the optimal key point of the cattle.
Yes. What is the optimal key point of the cattle, and how to if we collect or if we have different postures of the cattle, how can we label the correct key joint positions on these images? Yeah, this is a very important problem.
Yes, if we can decide how to say the optimal number of key points, maybe everybody,
yes,
will trust. Yeah, because currently we have no definition.
No idea, right? No idea.
No definition.
Yes.
Necessary or not? Yes.
currently we have no definition. Yeah, so that's why we try to do such research work. Maybe we can we can open our data set for the researchers if we successfully construct the AI models to recognize the skeleton of the cattle.
Yeah.
I think it's a good contributions in this
Yes.
area.
Yes, very good idea. Yes. Yeah. Aninako, do you have any
Okay.
question? My student wants to ask some questions. Yeah.
Okay.
英語をじゃあ、
いいよ。
部分的に、細かいコードを見るのに23個のキーポイントがいる。
これはピク、歌。
簡単なコードだったり座ったりを判断するだけなら、どれぐらいのキーポイントでできるのか。
My student would like to know how many key points are necessary to differentiate only the sitting and standing.
Yes, good point. I think maybe we have to know the key points of 4 legs.
4本の足。4 legs.
The key point of 4 legs. Yes.
And the back and the neck. Leg, 4 leg and the neck and the hip and
Yes.
the tail. That 4 leg and the neck and neck and the tail and the hip is the important key point, I think. Yeah, just this 1, 2, 3, 4, 5, and this 1, 2, 3, 4.
So maybe we can show the peak. So the past research result for the peak behavior recognitions. We can show some slide. Yes, like this.
Yeah, this one.
So like here, like this. So in the past research result, we define as shown in this slide, we define 23 key points of the peak, like this. And we can show some videos to determine the sitting down behavior of the pigs.
Sitting down.
Oh, next, yes, maybe slide 7 or slide 8. No.
Like this.
Yeah, like this. So here, this slide shows the second picture shows the pig who is sitting down, right?
Yeah,
So
this is sit down.
So if we can determine the enough number of key points, we can use such information to identify the sitting down behaviors of the pig or lying down, like this.
So similarly, 23 key points, estimate average of 23 key points would be enough to determine whether the cow is standing up or lying down.
Yeah, maybe not really so much key point informations. Maybe I think, for example, in this slide, we know, like this. So the pig is lying down. So we know each leg of the pig consists 2 key points, right? In this picture. So they can recognize 2 key points of 1 pig leg. And recognize the 4 key points for the whole bodies. For example, the key points number 5, number 6, number 7, and number 8. They can determine the body shape of the pig. And the key point number 12, for example, number 14, number 16, and number 20, we can determine the leg behaviors. So we can use such information to classify the 4 behaviors of the pig. Yeah, like this.
Yeah. So that is why you can differentiate the line on stomach or general line. Yeah.
Yeah.
Line.
So as I remember, your lab has already do some research to determine the cattle's leg is got hurt, right? Or
Yeah.
how to say this? You have to show the cattle the leg when they're walking, their leg is not balanced. The walking behavior is not balanced.
Yeah.
Yeah.
So lameness. Yeah.
Yeah, lameness. Yes, lameness.
Yeah,
So maybe
yeah.
we can, if we can recognize the key points of the cattle's leg, we can use such informations to determine lameness. Maybe also can use the informations to do this.
Yes.
And then we also can use the information to recognize the sit and lying standing or some difference or abnormal or normal behaviors of the cattle.
Yes.
Yes. So that's why the major important issue is how can we let our AI models can recognize the correct key point positions from different behaviors. For example, if the cattle is lying or if the pig is lying, we have to recognize the 22 key points like this. And when he sits, the key points is recognized like this.
Yes.
So we have to construct enough or a lot of data set for training, for AI training.
Yes.
So yeah, the another problem is how can we construct the ground truth, right? As I ask your students, what is the ground truth? This is a major problem. So what if you use the OKS to verify the performance of the AI models? We have to use the ground truth data to compare with the recognized results. So what is the ground truth? That's why we want to define the ground truth, the ground truth key points informations.
Yeah. So this is the problem everybody face such kind
Yes.
of
Yes.
Yeah.
Because we have used the human, we have labeled each 2D image, label each key points of the 2D image for pigs or for cattle, right? So if we label the image by several persons or several students, if we have no definitions for these key points, maybe on the right position or right numbers, so the data set is very not very standard. So the AI model maybe make the wrong recognition results.
Yeah. Yes, the accuracy of the detecting key point is very important for the
Yes.
Any question? Okay. Yeah.
So
Professor,
do you remember your student also do the work for the top image sensors to recognize the human body behavior, right?
Yeah,
in last years, and he labeled the key points of the human body by himself.
Yeah.
So I asked him in the ICC Taiwan 2025 this year. I asked him, so how do you know the correctness of the positions, the correct position of these key points you label?
Yeah.
Because I asked him to try to, if you that several students to label the positions, maybe everybody will label different position of these key points.
Yeah.
Yes.
It's on the so how to choose the key point depend on
Yes.
the yeah.
So also in cattle also we meet such problems.
Yeah.
Okay. So
Yeah, thank you. Yes, Professor. Yeah. Yes, very good approach. Yes, this is everybody face the ground truth of how to get the key point, the correct key point.
yes. Okay.
Thank you. Thank you.
Okay.
Thank
Maybe
So your students are so try hard.
very difficult, difficult difficult job, right?
Maybe we will do our best. Yeah.
Oh, you are visit again on November to Miyazaki, our conference. So
Yes,
please,
yes.
yeah, yeah. You should
Okay.
be present one by one.
One by one. Three papers.
At least three paper, but
At
from
least
Professor Aaron Lam, so many students. So you should bring 10 students. I have a lot of student dormitory. I already reserved for your students.
Okay. Thank you very much.
Yeah. So Professor, this time from our side, so we would like to present with the fish.
Okay. Fish. So
Fish.
Professor AKB didn't
Yeah.
attend this conference. So fish.
Yeah. Fish.
Okay.
Fish.
Fish recognition.
Yeah. Fish length estimation and weight prediction.
Okay.
Yeah. Okay. So you can see our slide. No.
No.
No. Not yet. Not yet.で、共有、表示、はい、このまま。OK? No. How about
What about now?
No. Not
No.
yet? Not
No.
yet.
Not yet.
でどうやったらいいどうやったらいい金の子わかるね共有。今共有じゃない共有は Windows で、これですね。共有します。How about this?
Yes.
Okay.
Yeah, it's okay.
So it is the first slide. It's okay.
Okay. Yes.
Okay, please.
So good evening, and today I am going to present about my current research, which is about building the pipeline for fish land estimation, weight prediction, and growth analysis. So aquaculture is a rapidly growing sector, and it is a very important role for the whole globally. So effective aquaculture management, it requires effective monitoring of fish growth and health. And when trying to monitor the fish or when trying to measure the length of the fish, it has to be done manually, and it is a labor-intensive process. So a lot of computer vision techniques have developed to
Okay. Yeah. Okay.
So while a lot of computer vision techniques offer non-invasive approach, a lot of approaches may still be very difficult to implement. For example, some studies often rely on underwater or side view cameras, which can be very costly and complex. So this study aims to explore the top-down visual data using a simple camera setup, which I will show you later in the data setup. So the problem statements are the manual measurement is labor intensive and it can cause stress to the fish. And there is a need for objective assessment of whether feeding strategies are achieving the desired growth. And then we need a data-driven estimation of when fish will reach the target size. So my research objectives are to develop a non-invasive measurement system, and then to develop a pipeline, evaluate a deep learning pipeline that detects, segments, and extracts reliable length estimates from video, and then compare different length measurement approaches to identify which is the most accurate approach. And then when we get the pixel values, we would have to convert them into real world units, such as centimeters. So what I'm trying to do, the third objective of my research is to find the best calibration methods and use those data to assess the growth of the fish over time. So currently, the pipeline that I'm developing right now includes, firstly, to acquire the data and prepare the data, which can be used in later stages, which are in detection and segmentation of the fish. And right now, what I am working on is the length estimation phase. So today, I will be going in depth about the length estimation phase, which includes these 8 steps. So first of all, the frames would be extracted. And then after that, the extracted frames will be detected with RY restriction. And then from the candidate frames, we would reduce overly similar frames. And then after that, the key frames will be segmented and then apply the quality filters so that we provide stricter rules to extract the length from the straightest fish only. And then after that, we would score the straightness values and then determine how many frames would be best to calculate the estimation of length, and then extract the length, and then we would move on to calibration. So before all of this, I want to explain a bit about the data that is currently used right now. So the data includes 12 different samples, 12 different fish, which are taken, the videos are taken in 3 different days, such as day 50, 60, and 70 of days of culture. So in total, there's 36 videos. And the setup is the setup is as shown on the right side of the slide. That there is a tripod and there is a camera that is viewing from the top to down. From the camera to the glass tank on the table. So when the data are acquired as videos, and then the data is prepared annotated using the computer vision annotation tool CVET. So there are key challenges. Sorry. So there are key challenges, which are water distortion. So as you can see on the left side, the top left video, the water distortion and the moving water surface distorts the ruler and the fish edges. So, and then there is the challenge of having reflections. So on the right top right video, there are multiple reflections that can be seen.
Mm-hmm. Okay.
And then, so the detection model works on detecting where the fish is. So if there are multiple fish visible in the video frame, it can detect multiple ones. So it is also one challenge. And the third one is the how can I say that? So when taking those videos, what I could see is that there is some kind of tilt when taking the videos. So the 3 pictures shown on the bottom, they were taken on the same day, but oh my God. Wait for a moment.
It's okay. It's
Thank
okay.
you.
It's okay.
So even though these videos were taken on the same day, we can see the visible tilt that means inconsistent taking of videos. So these are the key challenges.
Mhm.
And then another challenge is that when fish to swim in the water, the fish has to move constantly, and it causes like some small curves in the body. And when it turns or when it accelerates, the posture of the fish differs and it curves. So when measuring the length of the fish, if we use the bounding box length of the fish, it is not going to give the accurate length because the fish is curved inside the bounding box and the length is going to be underestimated. So what the approach that I'm trying to do right now is to find out the frames where the fish is the straightest amongst other frames, and then use and prioritize those frames and use them in the later length extraction phases. So I won't be going very in-depth about these models. This is a detection model that I've trained. The input will be the tank images and video frames. And then through the detection model, we will gain the fish bounding boxes, the class labels, and then the confidence scores. And moving on to the segmentation model, similarly to the detection model, the tank images and video frames will be input, and then the fish bounding box labels, and then the fish mask, the segmented mask will be provided. So for since I mentioned that I will be going in depth about the length estimation phase, here are the 8 steps, and then I will be going in depth about these 8 stages. So first of all, the stage 1, 2, 3. So firstly, every 5th frame is extracted from the video. So this balances the coverage against processing time, which means that it acquires enough poses without using a lot of near identical frames. And for the stage 2, the YOLO V8 is run on each extracted frame, and frames are passed only if the detection confidence is greater than 0.75. And if the fish bounding box is fully inside the inner 80% of the frame. As I've mentioned, there can be reflection on the side of the tank since it is made of glass. So by using the ROI restriction, we restrict those reflection problem. And then I use the IOU deduplication, which means that the frames are compared using intersection over union. And if 2 frames overlap by more than 85%, which means that if, for example, if there are candidate frames, 2 candidate frames, but if they are very similar, if they are similar to over 85%, then they are, one of them are dropped as near duplicate. So what we're trying to do is by using this deduplication, we aim to extract frames where the fish is in different positions or in different postures. So the next stage 4 and 5 is segmentation and quality filters. So the segmentation is when after getting the candidate frames, the segmentation is run on those frames. And it provides a pixel level mask of the fish body. And these mask coordinates are mapped back to the original frame resolution using the model's built-in coordinate mapping to avoid offset errors from manual resizing. And then after segmentation, I apply other quality filters to make sure that the fish is straight. So for example, the mask must cover over 30% of the bounding box area, which means that the fish is fully inside of the bounding box and it should cover over 30% of the bounding box area. And the second one, mean skeleton ratio, it means that the skeleton must be over 50% of the bounding box diagonal, which means that if there is a rectangular bounding box, the skeleton should be over 50% of the bounding box. It should cover at least half of the bounding box. And then there is OBB, which is the oriented bounding box. So the normal bounding box uses the horizontal bounding box, but the oriented bounding box, it adjusts to the fish orientation and direction, and it tilts so that we get the length of the fish correctly. So here I included the oriented bounding box length by skeleton length, which rejects heavily curved fish. And then there is the mask ROI coverage. So the 90% of the mask pixels must lie inside the ROI. So we reject frames where there are rulers or other tiny particles outside of the valid zone. So moving on to the stage 6 of the pipeline, we calculate the straightness score. We calculate the straightness score, which is like, for example, the curvature ratio is, it means that the deviation of skeleton points, the curvature ratio, to explain it clearly, for example, if 2 points are connected as a straight line, and then if they are connected through the skeleton line, those 2 points are very different. So if we divide those two, if the value is low, it means the fish is straight. If the result is high, it means that the fish is curved, varying from the straight line distance. And then the another one is the oriented bounding box and the skeleton. The ratio of the oriented bounding box to the adjusted skeleton length, if they are closer, it means these two measurements agree. So after that, we select the top candidates, and then what I'm trying to do is using the number of frames, which would be best to estimate the length of the fish. After that, I moved on to length extraction, and I extract 5 measurement types: the raw skeleton, the smooth skeleton, and the adjusted skeleton to meet the correct mask endpoints. And then the bounding box length and the oriented bounding box length. What I'm currently trying to solve is the pixel to centimeter problem, and because we cannot use a fixed pixel to centimeter ratio, as I've mentioned, the camera height stays the same, but the tilt angle is different, so we cannot use a fixed pixel to centimeter ratio. And we cannot use the ruler in the tank because the distortion causes automated ruler detection unreliable. So our current approach is using 4 calibration strategies by clicking the ruler manually, and there is a per day regression, and then the global regression and day feature regression. So these are the methods that I am trying right now. I won't be going to very in-depth about those methods, but these are the features that I am currently testing out. Thank you very much.
Okay, you finished. So, Professor, do you have any comments?
Okay, thank you very much. So, Wei-Yan, so both you have any questions? Wei-Yan and Bo-Heng, Bo-Yun. Yeah. Do you have any questions?
Yes. If a fish, you know the length of the fish, and if the fish is many fish, and how do you know this fish? Which one is how long?
So you mean
You use
when
fish or
so when multiple fish are included, do you mean that?
yeah.
So currently I still haven't moved on to that stage, but later on I am trying to move on that stage by using tracking of the fish and assigning ID to it so that we can differentiate the different lengths.
Okay.
Ready? So try to identify which fish.
Yes.
So give each fish an ID. Really? Yeah, I think it's very difficult.
Yes.
So if
yeah.
They are very similar, different from cattle. Maybe cattle have different shape and different colors on their face, right? Because the
Yes.
fish is very similar. So how to do this?
So that is why I'm currently doing research with just one fish. So even
Okay, yeah.
at least if we can get the measurement from one fish, we can later use it to develop into later stages where there are multiple fish or there are occlusions.
Okay. So another questions? Wei-Yuan and Bo-Yun.
Oh, yeah.
Bo-Yun, Wei-Yuan. Wei-Yuan and Bo-Yun. Hello?
If the fish is have 2 fish, because you say the IOU is over 85%, you will not count that fish in slide. Which slides? The IOU, that one. And if the 2 fish is the 2 real fish, because you say have the those reflection is 85%, and you will not count it. Yeah, this one. And if it's 2 real fish, is IOU is 85%, and it will be counted or not.
So it depends on the purpose, because my current purpose is to detect one fish and then extract correct length to extract correct length. So the aim of my current research is correct length measurement from the data, from the video data.
Because they would like to know the growth of
Mhm.
every
Mhm.
week.
Mhm.
Yes, currently they measure to extract those fish from the pool and measure manually. So that
Mhm.
is why they want to change, if possible, by using the camera data.
Mhm.
So at least they don't have to hold the fish when they want to, measure them.
Mhm. Mhm. So what is the application scenario of this approach? So how to use for the farmer in the aquacultures?
So our collaborator from the Thailand University, so they
Yes.
are conducting with the, how to say, the chemistry. They are the biochemistry, and they make the sun food for the fish and crab. So that is why which feed is more better and more appropriate for the growth of the fish. So that is why by using different kinds of feed, and they want to know the growth of the fish in
Yeah.
yeah.
So in the fishing pool, like this, in the fish.
But for testing the feed, so that is why it is not necessary to go to the pond at first. So within the tank, so they want to estimate the length, the measurement of the fish at first. But and later, so we need to go to we need to know in the real pond. It is in the late, maybe after that, after we progress. Yes, it's currently
Well,
only in the tank.
okay, yeah. So okay, so how to so right now is the manual measurements. So like the first one picture in this slide, right? So the he used the ruler to estimate the length of the fish.
Yes.
So they put the fish on the tables
Yes.
Yes,
and
currently.
the estimate one by one.
Yes. So the ground
So okay.
So the ground truth data was collected like that. So they would remove the fish from the water, put on the
Yes.
table some kind of flat surface, and then use tape measure or ruler to measure the
Yeah.
length.
So how to installations your systems in such scenarios? Put the camera on the top of the fish pool.
Yes. So the camera setup, as shown in the camera setup, we can So from the
Like
top
this.
of
Okay.
Currently, and the tank is only just like this environment, but in the later we need to consider in the phone, so we have to include the camera in the phone. Maybe because this is the reality. From the top view, it's not possible to get the fish.
So I see. I see. Yeah. So in the real application scenario, it might be a lot of fish in the pool, and you have to first have to identify uh, the fish ID and to check which fish, the length of each fish. Is
But
that
they
right?
do not like they are not necessary to identify each fish. So because
Okay.
a lot of fish, more than 500 and 1,000 and maybe so many, so they
Mm-hmm.
only want to know. So they are the same batch. So that is why they eat the same food. So that is why they want to know the growth of the average of those fish.
Oh, yeah, I know, I know. Yeah, so the growth of the average of these fish.
Yeah.
Okay. So yeah, let me think. In Taiwan, I have s- um I have so the very similar approach like this, because we estimate the shape, the shape, the growth of the shape.
Yeah.
Very similar, and the average groups of these shape. So how they do is that they also install a camera on the top of the pool, the shape pool, and recognize the shape by the bounding box, and they calculate the region or the area of each bounding box to estimate the average length or the average length of the shape to identify the growth of these shapes. So they don't have to estimate the length of the shape one by one.
Yeah.
On average. So they can, if the camera is installed on the pool, they can recognize a lot of bounding box. Each bounding box implies one shape, and they calculate each bounding box, the area of each bounding box, and the average of these bounding box to know the average growth of these shapes in the pool.
Yes.
It's very similar, right?
Yes.
And the
AKB,
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 yeah.
Professor.
It's a similar to the shape.
Yeah,
Yeah.
very similar to shape in Taiwan.
But
Yeah, also.
actually, I think it's so many paper is published in past 10 years. So I think maybe we should to do some survey paper, this work. In our school, we also has estimated the length of the shape, but we also to consider the real situation, because actually we need to consider the water depth and the water dirty. So maybe the camera cannot install on the top of the tank. Maybe we need to
Under the water.
consider to underwater.
Yeah. Oh,
Yeah.
yes. Yeah, install the camera under the water. Yes.
Yeah.
Yeah.
Yes.
You
So
can make,
they also would like to know the weight, not only the length, also the weight is necessary. Yeah. Fish weight is also important. So that is why
okay.
they are trying to the relation between the length and the weight.
Okay. Oh, yes. So do you have any comment, Professor AKB?
Professor AKB, are
Yeah.
you in
Maybe I can
Right.
provide our material from our school for your reference. Yeah.
Some research materials.
Yes.
So how many kinds of fish we want to recognize? So there are a lot of kind of fish will affect the correctness of your approach if the fish if different kinds of fish.
Since the main purpose is to extract the length, and then
Okay.
and then later use it to convert the length to weight, so that we see at which rate the fish are growing. So it doesn't matter what kind of species the fish are, as long as we know the length and then convert it to weight, we can fulfill the purpose of this research.
Okay. I mean is that if we collect the data set of the specific fish like this kind of fish. So it's also enough to determine other fish by the bounding box. Have you
Yes.
tried it to determine maybe the goldfish or or other different kinds of or other colors? Maybe some fish have different colors. Maybe the more black or more yeah, different colors of of their bodies may may affect the correctness of the recognition.
This is a very good point. I think I also think that I should test with different species so that I can see the difference.
Okay.
Thank you
Yeah.
very
Yeah, very interesting.
Thank you, Professor. So we need to decide for the next month meeting.
Yes,
Before
yes,
we
yes.
arrive to
Next month's meeting maybe is very close to ICCE Taiwan, right?
Taiwan for the practice, the practice for the students. Nemo.
Nemo,
the
yes.
Mhm. Because he is now working hard to submit the GCCE, so that is why he currently today.
So
easy.
July, so you are already stay in Taiwan on July 30, right?
Yeah, so we will arrive on June 30.
Yeah, 30.
Yeah.
So Professor
before-
Cici, you don't forget to attend the OC dinner in the
OC on
yeah
June
on July 39th.
39. Okay.
Yeah, yes. Okay. So let me check. How about July 23?
23 is okay. Yeah, it's okay.
AKB in Japan or not? AKB in
Japan?
Japan or not? Maybe he is in Japan or not?
Maybe
Whether in Japan or not?
Professor AKB, how many times you visited to Japan after you returned
One
back
time,
from
average one times per month.
One time per month? Please visit to our university. Please visit again to Miyazaki, Professor.
So 23 is okay for you?
I think it's okay.
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 Yeah, we are okay. At
Okay.
18,
So
18.
okay, the same time. At the same time, right?
Yeah.
Okay.
So
So
I would like to discuss with you. I am now thinking to visit on July 4 to one university. Professor Pan recommend me that university would like to visit to our BTCA conference. The president would like to visit to BTCA conference. So that is why I would like to visit to that university. This is I'm not sure. The pronunciation is Chaoyang University of Technology and Taichu. It is the private university. Taichu.
which one university? How
CHAOYANG. Chaoyang.
朝阳
Taoyang is located at
in
Taichung,
Taichung.
not in
Yes.
Taoyuan.
Taichu.
Taichung.
Yeah. So we can visit the one-day trip by using the Shinkansen. Not too far.
Cannot direct to the university. You take the Shinkansen to Taichung,
Taichung.
then you have to take a bus to Chaoyang.
Oh.
Yeah.
So if we go around morning, we will return back on the evening to Taipei because we will stay the same hotel, conference hotel, the continuous day. Because our flight is the July 5.
Yes, I know. I see.
Yeah.
I see. July 5, right? So you have to arrange schedule on July 4.
July 4, yeah. July. 1 3. Yeah.
So AKB, please turn off your microphone. There's a lot of echo.
Okay, sorry.
So have you? So this is the final schedule. Visit to Chaoyang.
Yeah, because we have only 1 day. So I
Okay.
think at first our last meeting. So shall we go to the Professor AKB University? But I think next year we are sure
Okay.
to be
Okay.
Professor
Yeah. Next
AKB
year,
University. Or
ICC Taiwan is
Taiwan.
also
So
at,
that is why this
okay.
time we should go another place.
Okay.
So
Okay.
for that, how do you think? So it is available to visit to the university from only 1 day. So because I would like to return back to the Taipei on that night.
Oh, I think it's okay.
Okay.
It's okay. Yeah. For 1 day, you can visit the Chaoyang University and go back to Taipei. It's okay.
Yeah, because according to Professor Pan's message, so the president of that university will need to attend the BTCA. That is why I include the one-on-one general chair. This is the president of that university. Yeah.
Okay. The President Chai, the President
Yeah.
Chai, right?
Yeah, President Chan. Yeah. He will attend with the one team to our BTCA. Yeah. So that is why I include in the honorary chair. Another one is Professor, I do not know that university name. This is from China. So that professor is very much related to our vehicular technology and transportation. Professor Pan recommend me to include one general chair. This is the professor from China.
Okay.
His name is the Xiao. Now, how to pronounce? Xiao Guani. And this is the School of Transportation and Logistics, Southwest Jiaotong University, China.
交通
Yeah.
交通 University in China.
Yeah, so School of Transportation and Logistics, Southwest Jiaotong University, China. So,
okay.
yeah, Professor Pan recommend. So that is why I include that one professor to the general chair. He said he will bring some attendants, and so they will join with our conference. He said.
Okay.
I am not sure because the relation between Japan and China is not good. We can go easily or not. They can come or not.
The relation between Taiwan and China is also not good.
The currency is not good.
Let's find the relation between Taiwan and Japan is good.
Yes, good, very good.
Because both of us have bad friends.
Yes.
Okay. Yeah. I think it's okay. So visit to Chaoyang University 1 day's trip. It's okay.
Yeah. So Professor AKB, so next time ICCE Taiwan, please make the promotion our conference PTCA, because we can extend some more days of our paper submission.
Okay. So maybe in the banquet.
To extend until August or September is okay, he said.
Okay. So this time in the banquet, do you want to arrange a time slot for you to promote the VTCA conference?
Yeah, Professor AKB and Professor Ellen, please, because this is in Taiwan. So
okay. I will ask the general chair to arrange a time slot for you to promote the VTCA conference in the banquet. Okay, it's sure.
Yeah, so we would like to collect more paper.
Okay, so Professor AKB, how many paper will you submit in your special session? At least 10 papers.
Maybe paper.
Professor AKV, please correct many papers.
Currently, submission is not available. So I think we need to solve this problem.
Okay.
Yeah. We will solve the problem. Yeah.
Okay.
Yes. So this homepage is maybe how to say updated by Lemon. So I will ask you Lemon very soon. Yes.
Okay. Okay.
Okay. Thank you.
Thank you.
Okay, Professor. Yeah. Thank you very much.
Okay. Thank you very much. It's time
Also,
for
Cici, Professor Cici,
Yo. Okay.
we need to provide paper template.
Paper template. Okay. So I asked to Professor Ba. He said so. Maxima is 10 page for the one page. So 6, maybe about 8 is also okay. He said, but one page, one column. 2 paper summation is one column page. The maximum is 10, 8, 7 or 8 is okay. He said. So I will submit the template very soon.
Okay.
Yeah.
Thank you.
So, so I would like to request your idea. How long we should use the abstract submission for 200 words, only for the presentation, not including the proceeding. In that sense, the abstract should be 1 page, or how many? 1 page. Short submission only for presentation. Do you have any idea? Please advise me.
I think maybe about 200 to 500 words in a page.
Okay, 500 words. Okay, for only the abstract submission and only the presentation. It is for.
Yes.
Okay. Okay, Professor. Yeah. So I will discuss you on next month because I have our project report for this month. So
Yes.
that is why I know checking my site. Yeah.
Okay.
Yeah. Thank you very much. So
Okay, thank you.
Professor Allen, please submit more than 10 papers from your.
Okay, I will try do my best.
Yeah. So please bring all of your students from your laboratory. Those guys also.
Yeah, I need a lot of money.
I will arrange a lot of our dormitory for our
Okay.
students. Yeah.
Okay. Okay.
Yeah. Thank you.
Okay. Thank you.
Thank you.
So now, so it's time to have a dinner in Japan, right?
Thank you so much. Yeah.
Okay. Okay. Thank you. Thank you very much.
Thank
See
you
you
next
next time.
See you
Yeah.
next time. Okay.
Yeah.
Thank you.
Bye bye.
Okay. Bye bye.
Bye bye.